Hello, everyone. Whoever's waiting. Sorry, I am just making sure everything works first before we start. Hello, everyone. Whoever's waiting. All right. I guess the audio is just grainy on my end. Um, so I wanted to start out by saying once again, let's have a little disclaimer. This video is for, let's get my homepage out of the way. That's disgusting. This video is in no way endorsing modification of Marvel Contest of Champions. My aim here is just to inform you of some of the different ways that modders attack Marvel Contest of Champions, and in general, different ways that you can modify games. Or if you're just curious about how things work, you can dig under the hood a little bit. Hey Ryman, what's up? Um, so in the last part, we discussed how Marvel Contest of Champions is built under the IL to CPP pre-compilation process. And we got to the part where we were kind of digging into the functions. We talked about dnspy, how we can extract the symbol names and addresses for different functions and fields within the game. And then we got to the point of disassembly, um, and actually taking a look at some of the code, but we didn't really get to a point where I identified, hey, this is a mod, and this is how you make the mod. So that's what I'm going to be doing in this video. Um, so I'll start off. I took a look online to just really get an idea of what the mods out there and what like the like most complex mod I could find. And from what I found, there was a modification. I'm not going to link it anywhere. I'm not going to show you how to get it. But there's a modification out there which allows you to, one, draw over the app and dynamically choose your stat multiplier, like crit rate boost, damage multiplier, health multiplier, and things of that nature. And you can completely turn off the mod as well. So what I showed you last week, you can't do that dynamically. That's just a static one-time compile and then re-upload and you're done. So I took a little bit of a closer look at the file and I'll show you. Oh, that's not where I wanted to go. I have some of these tools already set up because it um, didn't want to work for me earlier. Where where did I put these? Oh, tutorial, right. All right, so this first file that I'm showing you here is the actual game itself. I'm sorry, this one is the actual game itself. Unmodified, just downloaded from the APK from APK Pure. Um, and we can open it up and we can see that's basically what we talked about last week. It has an Android manifest. It has your IELTS CPP library, 64-bit and 32-bit, and it has all the resource files. So the second APK that I'm showing you right here is the modified file that I just discussed. Um, this is the one that can control over the app, and you can turn it off and on, stat boost multiplier, etc. So I took a look at this and I noticed some things. Let's see if I can pull up some of this. So the first thing I noticed is that there are different files in this, obviously. You can see here we have two dex files, which are just compiled Java files. The workflow there goes to Java, small e, and then all the way down to dex files. But here we have 3, 4, 5, 6, 7 dex files. And then if we go under lib, we can see that the 64-bit version is completely gone, forcing you to install the 32-bit version. I'll explain why that's important in a little bit. But you can also see if we go into this is the actual game code as we discussed last time. And you can see here that there is yet another additional file. So if you first, this is the main game code, the file size, 67,028,688 bytes, and it's exactly the same here. So nothing, and then you can see the CRC, which is just a file integrity check over the entire file. That matches exactly what we see from the original file, meaning they didn't touch this. Sorry about that. My Wi-Fi randomly disconnected. Um, my bad. All right, what was I saying? Just one second. Let me make sure everything is fine before I continue. All right, we're good. We're good. So anyway, so what this means with the CRC being the same and with the file size being the same, it means they didn't adjust the actual game code at all. What they did is add this file right here, libmt.so. Now, I don't know, and MT could be, I don't know what they're meaning by that, mod something. But this is an additional file, and you can see it's created on November 17th, 2022. So this is a modified injection library. So how they're doing it is about what I'm going to show you, and I have some of the links in the description for different things that we're going to need in this tutorial. Um, is they're hooking into the lib-IL or the IL2CPP um, game management objects. So again, this is again very hard to explain without at least a kind of working knowledge about compilers and mail systems. But essentially, what happens is when you download the game, it goes directly into the hardware on your phone, right? So that's what we call non-volatile memory. It's not going to be overwritten until you either uninstall it or you reinstall it back. Um, what the game then does with IL2CPP is as the game loads, it gets stored to RAM, which is volatile memory, which you can overwrite over and over. So as these classes get loaded, which by the way, C++ has no knowledge of classes, so I'm just saying this from a high level standpoint, but as these get loaded, this libmt.so takes this game code and not from the original game code, but they'll overwrite it while the game is running. And that allows you to bypass lots of integrity checks where you just don't have to deal with a lot of the security that's involved. Um, there are different tools where you can sort of scan the memory while it's going on. I'm not going to show you that. That's a little bit boring for most people. But I'm going to show you right now how you can make a very simple injection library and do not exactly the same thing. That took a little bit more time than what I'm about to show you. But we have one interesting function that I managed to find. And what we're going to do in this tutorial is we're basically just going to say you're invulnerable all the time. All right, let's exit out of these. And let's start. So in the last tutorial, I showed you the dance bar. So I was doing a little kind of detective work. And I came across this ultimate player controller class. This is code that was written by Kabam, obviously, because it has a bunch of stuff that is, not something that's portable or other stuff is directly related to the game. Um, so here, and I like Booleans. Booleans, if you don't write code, essentially are just things which are a check for true or false. Is something this way? If it is, return true. If it's not, return false. So Booleans can be great attack vectors because you can force it into, instead of checking it dynamically, you can just force it to always return true. And I kind of explained that a little bit in the last video. But anyway, I came across this little guy. This field name is immune to damage. So I went and we talked about what offsets and virtual addresses. Um, So I copied this offset and we went, I already have this kind of pre-pulled up. Yeah, so, and this is the actual game code for Ultimate Player Controller is immune to damage. I know this looks like a lot of like jargon because it is. It's assembly code. It's not something that's easily readable unless you were used to looking at assembly code. But because we're able to import names, we can get a simpler idea of how things are working. Um, a little prefix to ARM code. I did a little bit of investigation after the last video because ARM is just not what I normally work in. Um, but the main point that we're going to focus on in this video, this is a register. There are lots of registers contained within your processor, but just to give you a high level idea of how things work, if you have a function and it's returned something, um, I'm going to keep this very simple. This is a very simplistic point of this, but W0 is where it gets deposited to. So anyway, high level, I know, boring. Let's get into all this finally. Browsing through this, you can see there is another method contained within this method called health is invulnerable. So if we click on that, you can see, hold on, let's see if we can make this a function before. Yes, thank you. All right, that this is a very simple function. It simply just has an input, which is health, and the method. Well, this method pointer right here, this is contained within all IELTS CPP classes. That's kind of important when we get into the library injection, but for right now, there's only one input to this, and it is essentially an argument for is it invulnerable. And so that compares against W0 register and then returns true or false, depending on what the value is for WZR. So what we can do here, and so I linked in the description a couple things that might make things easier for if you're not used to looking at assembly, if you just want to write high level code. Um, but compiler explorer, yeah. So this is essentially the method that is going on right now. It isn't vulnerable, and then it returns based on some input, right? But we want it to return true at all times. So the output to that is this assembly code right here. Move W0, 1, and then return. And so if we do that, that method will return is invulnerable all the time, and so player will be invulnerable all the time. I'm gonna stop shortly with all this like low level talk. I know it's very hard to keep up if you're not used to this, but I need to explain this in order to get an idea of what we're about to do. So you can do this one of two ways. You can either directly inject this into the lib.iltcpp.so file, and then you have to deal with all the integrity checks. That's kind of what we did in the last video. What we're about to do here is we're about to take this and exploit how it gets deposited to RAM while the game is running. And we're just going to overwrite this function and constantly in a loop. It's called a POSIX thread, so it executes outside of the game thread. It will constantly update those addresses to be this function exactly. Any questions, please type. I know there's not that many people in here right now. But, all right, let's get started. So, to make a shared object file, we need Android Studio. Link is in the description for downloading Android Studio. You will need the NDK, Native Development Toolkit, as well as CMake lists. I'll explain what those do in a little bit. So, by the way, I have a working version of everything open right now. So just in case this craps on me, I can just I can just default to the working version. Android Studio. We're gonna open that up. It's gonna take a little bit because Android Studio takes a lot of resources. Come on now. can do it, Android Studio. I believe in you. They're gonna make me close this one first. All right, let's close this one first. Yes, exit please. All right, maybe now I can open Android Studio. I was hoping to keep that open just in case everything went shit, but now we gotta make it work. No, thanks. All right, new project. All right, pretend you didn't see any of this stuff in the background at all. Um, so we are going to use an empty project. Come on, go away. So we're gonna go here and we're gonna go here and select empty activity. You see there's a lot of different options. This is just making Android apps, whatever. So we're going phone and tablet, and we're coming here to empty activity. We hit next, and we're going to give this an application name, and we're going to say it is uh, inline hook MCOC, and that's going to give us a package name, exactly whatever application name is. It's com, whatever, and then inline hook. It's going to give us our save location in case we want to come back to it. Language is Java, Kotlin. This really doesn't matter for right now. We're not going to be using Java or Kotlin in this in Android Studio at all for this one. I like to use Java more, but whatever. Um, we do not want to use legacy supported libraries, and we want to stick on Android API 21. So we're going to hit finish. So Gradle is going to start to build our initial project. So we're going to have to wait a little bit. So it's still loading. It's a bit resource intensive, so we'll just kind of sit back and wait a little bit. Oh, while it's loading though, I do want to note something that we're seeing right here in on create. This is going to be important when we come back to after we've built our actual application or our actual injection library. All right, so this gives you a whole lot of like application information. But what we're going to do here is we're going to come up here to Android and we are going to go to project view. All right, so now we have a project view. Going to open inline hook MCOC. All right, first thing what we want to do is we want to go here to app, source, main, and then under source we're going to let me check my other file. Sorry, it's under app, not under source. Is sorry, I just want to be completely positive. All right, main CPP includes. All right, so under main we are going to add a new folder. Um, come on. New module. Oh crap, not module. What am I trying to do here? Directory, sorry. There we go. We're going to give this directory name CPP. And then we're going to add another directory under CPP. We're going to call this includes. Okay. So what we're doing here is we're setting up our base library. And we're setting up our folder, which is going to contain our C++ code. If you don't want to follow along and you just want the code itself, I put it on Dropbox and put it in a link in the description. Um, I might honestly just put this entire project on Dropbox and then put it in the description after. But in case you do want to actually follow along, here we go. All right. So the first thing that we're going to do is we're going to go to our Gradle build file. So build.gradle. What this does, what the Gradle file does, is it's just going to tell the application how to build itself. So we want to come in here and we want to specify that there are external libraries that, excuse me one second. We want to specify that there is we want an external native build. We don't want this to compile down to an actual application. We want it to be just native code. So to do that, we're going to come here in Android and right underneath our test instrumentation runner. We're going to do two things. First one is right here. We're going to specify it's an external native build. So this external native build needs to have a CMake file, which we will specify in a little bit. But for right now, we are going to leave this blank. We're going to give it C++ flags of nothing because this is a very simple shared object library that we're going to be doing. And then the other place that we need to have the external native build defined is we need to come underneath build type. And so in between build type and compile options, we're going here and say external native build again. Did I not spell that right in the first one? Hold on. Oh, I guess I did. All right, never mind. External native build. And this is where we're going to give it our CMake path, and then the CMake path for the CMake file that we haven't made yet, and then we're also going to give it the CMake version. So we'll specify CMake. A path. By the way, if you're commenting anything right now, I can't see it because I have a lot of windows open, but I will switch back to YouTube. So our path, leave it blank for just a second. So we're going to create under CPP, we're going to have a new cmakelist.txt. All right, just so we know where the path is right now, we're going to go back to our Gradle build file. Dang it, that's the wrong one. There's a lot of Gradle builds in here. All right, so we're going to specify that path, which is going to be src main cpp and then cmakelist.txt. So we're going to say src main cpp cmake lists. TXT is case sensitive, so please be advised. Then, by the way, the NDK and CMake is not enabled by default when you get Remote Studio. So what you want to do is go here to File, Settings, and then we're going to Tools. Oh, wait a minute. Just kidding. Where? Hold on a minute. Huh. All right, I'll find it in a second, then I'll tell you. Because I had it open on the other one. But you will need to download It's under SDK tools. I don't remember off the top of my head where SDK tools is, but in the SDK tools, you'll need to download CMake, and then you'll need to get that version number, and then you'll need to come here. For me, it's version 3.22.1, and you'll say version equals 3.22.1. All right, that's all we need to do right here. Sometimes I'm gonna put a little comment here. You might, let's do this first. You might need to come in here and say NDK version, which you can also find in your SDK tools. The latest one right now is 25.1.8937.393. We can do that. We can leave that in there. It doesn't really matter. But for right now, there's no purpose in having it. If we were doing to do more, we might need to keep that in there. All right. So now we have our build set up. This is just what this file does is just telling Android how to build the library and what file to look at to give us um, the CMake to in order to build the actual code. All right. So now let's add some code here. All right. First, I'm gonna check comments. All right. No comments. That's fine. I know this is incredibly boring for some people, but for me, I really love it. So here under CPP, we're going to add a couple C++ files. First one we're going to call main, and then second one we're going to call mem. Main is going to be our main execution code. So I'll talk as I go. We're going to add a C++ class. We're going to call this main. We don't want to create header only. This is going to create a C++ file and then a header file. I'm not going to explain how this works because I'm just going to assume you can go and Google how C++ files work and how header files work after the fact. That's not the focus of this video. So we're going to add a main C++ file, which is going to give us a generated header. And then we're also going to add another C++ class, and we're going to call it mem. All right, this is going to auto-generate some code for us. This top is a header guard, which prevents it from being compiled twice. It has a main class that's not something we're going to use because we're only going to be using functions. All right, first thing, we need to move our header files into our include files because that's how CMake works. Actually, it's just how our directory works. So we're going to make sure that we're refactoring, search for references, and now if you come into here to include, it's going to include our header files. So now that we have our files, let's go to our CMake list and let's specify exactly how we want to make our application. So this is going to be pretty simple. Some CMake lists gets really long, but since it's such a simple injection library, the first thing we need to do is we need to come in here and say CMake minimum required. We're going to say our version is 3.22.1, so we're just going to say version 322, which is all encompassing of 322.0 whatever. Now we get to specify our library. So here we're going to add library. So the first part of add library, and you can go into CMake. Maybe I'll post a link to how CMake works. But this first one is going to be our output library name. So we can give this a title of whatever we want. And this is how we're going to inject. So that other one that we just saw from the modded file was libmt. So why don't we just try to replicate that? We'll call it libmt. We'll call it libmtoc mod because we're not actually going to be doing this injection. So we can say mod, make it a little bit obvious. The next thing we need to specify is that this is a shared library. So SO files are shared object files. So in order to output an SO file, it's going to be shared. The next thing is we're just going to specify our two C++ files. and the order in which we want them to be compiled. So that order is going to be main C++ and then mem C++. Just two other things. We need to set our main include header files. So all we're doing here is set and then main, dang it, main includes, and then the path to our includes, which is source main CPP includes. And then finally, we want to specify the target include directory. Again, go look at CMake lists if you want to understand exactly how this is working. So we're going to specify our library name that we just named, which is libmcocmod. And then this is a public library. And then we are going to give it the parameter of main includes. Keep forgetting I have caps on while I'm doing this. Main includes. And that's it for our CMake lists. Let me check chat one more time. All right, nothing in chat. I'm gonna reload 1 second. Caps on while I'm doing. Sorry, just checking one thing. Okay, we're good. All right, so now we specified how we want the file to be built, the output library name that we want our output shared object library to be, and we've specified our includes. So now let's get into a little bit of code. This mem file, I don't know if I really want to talk about it. This is I did give you the game code. Let me think if I actually want to talk about how this mem file is going to work. You know what? I'll talk about it a little bit. So this main file is just going to have it's going to have three functions. So if you know how headers work, we're just giving this a scaffold. I don't know, that's not the right term for it. I just can't think of it off the top of my head. So first, caps on. First, we're going to have a Boolean return function of protect address. I'm not going to specify how this is going to work right now. Maybe I will in a second. So it's going to have a size, and then it's going to have a protection. All right. So all this is going to do is going to change the protection of an address within a given length. Again, not really going to go into it that much. All right, so this next one, more important that you understand, is a Boolean return, and it is a memwrite. This is exactly how it kind of sounds. This is a function which is going to write our code to memory and then return true or false whether it actually happened. So to memwrite, we're going to give it a pointer for the address we want to write at. We're going to, or not count, what am I doing? Const. We're going to give it a buffer for bytes to write. And then this is going to have a length of len. First of all, why are my type defs not included here? Oh, I know. Because I need to include a lot of different stuff. I need to first. It might just work if I sync it. Hold on. I'm not going to do that just yet. Yeah, if I sync it, hopefully it just works. Otherwise, I'm gonna have to go in to do all the includes for this, and it's gonna be a pain in the ass. But whatever. Um, and then we're gonna get the another function, final function that we're gonna do is get the absolute address um, of what this is the most important part of this header or this C++ file. This will dynamically get the function based off of address within memory space of already executing game code. And you can do this for pretty much any function that lies outside or lies inside IL to CPP. This doesn't always work, but in this case, it works wonderfully. So we have a unit pointer, and we're going to get absolute address. It's going to have a library name. Um, the library name is just going to be an address, which I'll show you here in a second. And then it's going to have a relative, what is it, unit pointer? Yep. Unit pointer T, relative address. So if you go back to dnspy, you'll see we have a relative virtual address here. It's not changed in this because it doesn't have any knowledge of the game memory space yet. But what this is going to do is it's going to allow us to retrieve that address based off of relative address. Um, ooh, can I just sync this? That'd be nice. Ooh, nice. All right. It included stuff already. All right. So I don't have to go in and specify a bunch of shit. So I'm not going to tell you how all this stuff works. I'm going to change this first because it's going to throw an error if I don't. I want to more focus on what's going on in the main file. The memory file is just how our library is going to handle memory manipulation. So honestly, what I'm going to do here is I'm just gonna go copy paste it from the old code. Because there's no reason why I need to explain all this stuff. All right, we're gonna copy all the way up to here. And again, these files are linked in the description if you want to just copy and paste this stuff. I can sort of explain how some of this works maybe in another video, but for time constraints, I'm not going to explain how this memory manipulation file works. We're just going to focus on our main file. Anyway, so that'll do it from them. Now for main. Oh, did I just put that in main? I didn't mean to do that. Undo. So we want to put this in mem.c++. There we go. Now for main. One sec. Check in the stream. All right. Our main C++ file. This is where the meat of everything goes on. What we're going to do in pseudocode is we're going to open a POSIX thread, and we're going to execute that thread in an infinite loop. This infinite loop is going to constantly overwrite data that is being sent from the non-volatile memory game code to the volatile memory that's get deposited. So in order to do that, let's say we have, and again, this is also included in the description. If you don't care about any of this, what's going on, and you just want to build a shared object file or an injection file, So we're gonna say void. I have it labeled in the other thing that my hack thread. Why not? Mm, yeah, my hack thread. Why not? I don't want to. In case I end up copying and pasting some stuff, I don't want to end up having to do anything else. So this function is going to be a pointer function. I'm going to explain just a second. Actually, no, that lies more in how C++ works. I just want to get kind of to it. So first, we want to make sure that the application itself is already loaded. So what we're going to do is we're just going to sleep in the thread for, I think on the other code I had 1 second. We're just going to go 15. Yeah, Alt Enter. Why are you not already entered? So, no, not 15 seconds. Should have been 15 milliseconds. All right, 1 second is fine. So we're going to do nothing for 1 second. We're going to make sure the game actually loads first. All right, here's where we want to execute a infinite loop. While true, this loop will never break. So unless we give it a reason to break, so let's say if something, then break out of the loop, this will execute infinitely. So anything that is done here will constantly be executing while the game is running. We're never going to break out of this loop, so we're just going to return null. It's not going to be happy about that because it doesn't think there's any reason for us to return null, but we're never going to break out of this while true loop. All right, so now that we have our memory C++ file written, what we want to do is we want to take this function that we were talking about earlier, where it's just saying move W0, WZR, and then we're returning. And we want to overwrite this entire function with something that just returns true. And you can see that it doesn't change much. All it does is it says move W0 and move 1. 1 is true, 0 is false. And then we're returning. So almost exactly the same function, but we're going to overwrite that function with this. So we're going to do that using bytecode. We can do inline assembly, but I don't really want to do that right now. So again, these are also in the description, godbolt.org. And then to make this, I went ahead and did it ahead of time. So this is the function, and then this is the assembly code, or the bytecode that gets written. So we're going to come here, and we're just going to copy this. We're going to go back to our inline hook MCOC, and we're going to say, whoa, buddy, I did not say come up. All right, we're going to say memwrite. And we are going to memwrite. First, we are going to do a reinterpret cast. If you don't know how that works, then please see C++. Our type will be void, I think. Yeah, void. And then our expression is going to be get absolute address. All right, so what we're doing here, just give me 1 second. I'm going to finish writing this out. So we're going to get the absolute address of libil2cpp.so. Remember, libil2cpp is our main game code that gets stored. The second thing that we want to do is we want to get the absolute or get the relative address of this function. So if we come here, you can do this one of two ways. If you're in a disassembler, you can either come here and say, oh, it's 19B3C0, or you can go back into dnspy and you can find it is invulnerable. For some reason that's not coming up. Maybe it's a protected space. I don't know. I'll have to look again. But for the sake of argument, it's going to be 19B39C0. So it's going to be hex form 19B39C0. All right. Let me finish up this function, then I'll explain what's going on. So you remember those bytes that we just copied? We're going to come here, and we're going to copy those bytes. And this has a length of 8 bytes. All right, let's break this down just a second. What we just did was we came here and we said, all right, libil to CPP is the main game code because we're going to store this object file within the same folder as the APK itself. And we're going to get the address for a function. So once we've done that, once we've gotten the address, now we are going to take that address and write these bytes to that address with a length of 8. And cast it as a void pointer, and memwrite just overrides the memory. Use of undeclared identifier memory. Oh, right. Hold on. It's not going to know any of my functions if I don't tell it to include. Includes num.h. There we go. Now it knows what I'm talking about. So this thread is essentially just going to overwrite the value for the OEM for the original Kabam code, and it's going to override it with the code that we want, where we just specified return true at everything. So now we need to execute this thread. This is also C++ related, so I don't really want to go too much into how it goes. First, we're going to tell the compiler that this is a constructor, so we're going to give it an attribute of constructor. Oh yeah, anytime in dnspy, if you see ctor.ctor, that's a constructor, and then there's cctor, which is a constructor pointer? I don't remember off the top of my head. Anyway, so we didn't include this in header file, so we need to initialize it. So now let's create our actual function, void initializer. Yeah, this is C++, not C. I don't know why I'm giving that a void input. I was writing C today, so. So like I said, we're gonna have this executing in a POSIX thread. If you want, Google POSIX thread and how that works. I'm not gonna explain here. So we're gonna give it our typedef pthread, POSIX thread ID. So ptid, we're just gonna specify that it exists right now. And then pthread create. Yeah, we forgot to include that as well. Pthread create. So we're going to specify the address of the ptid or the pthread ID. It is going to, I'm not going to, okay, I'm just going to say what everything's going up. So this is our thread, my hack thread, and this is also null. Again, if you want to learn what else is going on, just Google how pthreads work. It is beyond the scope of this video. So what we have here, let me think if there's anything else that we need to edit. I don't think so. I think what we have here is a ready to build and execute APK. So we can test that theory by going and we're going to make the project. Go to our build view. Got to give it a little bit of time. So we're finally getting to a point where we're actually making code, and this is the actual injection project. It's going to take it a little bit of time. One more thing to do. Oop. Oh, I didn't include standard IO, did I? I didn't, did I? Um, Hold on. Crap. Can I get the error message, please? What is the name of this stupid library? I forget what size T is in. I think it's just standard header. Let me try this. Is it main that it's not liking? So we'll go main. Um, Actually, we're including mem, so let's go mem first. And maybe that'll fix all this junk. So we're going to include standard IO, H. I'll get rid of a lot of those. What else do we need to include? We need to include, oh, we need to include string. Sorry, this is a lot of stuff that I forgot. Include all right, so if you're following along, just include these headers. Dang it, I messed that up. Not sysmain, what am I doing? There we go. That's what I meant to type. Again, outside the scope of this video, but there are just some things which we don't want to rewrite. And then we also want to include our pthread. I'm not even sure how it's working without the pthread header. All right. We included mem.h, so this should be fine. We're going to clean and rebuild. So